In this DiGiCOR demonstrates, we'll be taking a look at the QNAP High Availability feature. With the QNAP High Availability Manager, it allows you to create a high availability cluster using two QNAP NAS devices, one acting as the active server and the other as the passive. If an unexpected failure or an issue with the active server occurs, then the passive server provides immediate protection with automatic failover. This ensures continuous storage service and system availability. In order to take advantage of the QNAP High Availability feature, we need to look at what the requirements are. As just mentioned, you'll need two QNAP NAS devices, and these NAS devices need to have the following identical specifications. The two QNAP NAS devices need to be identical device models. However, when configuring them, they do need to have unique host names. The total memory capacity on each QNAP NAS device needs to be the same, and the High Availability Manager requires at least 8 GB on each NAS. The storage configuration must also be identical, and we'll take a closer look at the storage requirements in a moment. And lastly, the network connections need to be identical. And just like the storage, we'll look at more detailed network requirements in a couple of pages. From a software standpoint, they both need to be running the same firmware and operating system version, and they both need to be running the same version of the QNAP High Availability Manager software. It's important to note that any unsupported applications must be removed or disabled from the NASs, and you can check the app compatibility on the QNAP website on the link shown. Furthermore, if you have any software that requires additional licensing, the types and number of valid activated licenses must also be consistent between the two NAS devices. Just a further note on the storage. So we said the storage configuration needs to be the same. And what that means is that if you have any disks that are installed in the NASs, they must be installed in the same slots in both devices. For example, if you have two drives installed in a 4-bay NAS and you have them installed in the first and second bays, then they must be installed in the first and second bays on the second NAS. Furthermore, for each drive or disk that's installed, they need to be the same capacity. Now, this extends to both M.2 devices, hard drives, etc. And lastly, all storage pools must be in a healthy state. Obviously, it goes without saying that if you are synchronizing and making sure that data is available on both, you want to make sure that the storage pools are in a healthy state so that there are no errors during that synchronization. From a networking standpoint, there are two networks that will be configured during a high availability. The first is the cluster network. This is the network that's used for client access. So if you have servers or clients accessing a NAS share, the NAS devices need to be using the same network interface on both devices. So if you're using the first port or port 1, they need to be the same on both NAS devices. These can't have any virtual switch configurations applied to those ports, and those interfaces must be assigned a static IP address on each NAS. And these IP addresses obviously need to be in the same subnet so that in the event of high availability or failover, your clients can still access those devices. When we set up a cluster, we'll be setting up a virtual IP address that will be used to access the resources, and that will also need to be set up in the same subnet as the cluster network IPs. In addition to the cluster network, we also have a heartbeat connection. The heartbeat connection is going to be using a network port which is going to be directly attached between the passive and active, or the first and second NAS device. This is the connection that enables the data synchronization between the two devices. And again, like the cluster network, you need to make sure you are using the same network connection or the same network interface on both NAS devices for the heartbeat. Because this is the network that will be used for synchronization and ensuring the other devices, both devices are contactable and alive, QNAP recommends using the fastest, lowest latency network interface for this purpose. Like the cluster network, this can't have any VLAN or virtual switch configurations applied. And it's important to note that this interface must be assigned a DHCP IP address. So with all this, let's put it all together. In our demo environment, which we'll be looking at shortly, it consists of two NAS devices. Our first one is a TVS H474, and because they need to be identical models, we have a second one, TVS H474. Both of these are a 4-bay NAS that meets the minimum requirements, and of course, there are a number of models that are compatible and support QNAP's high availability. This list is available on the QNAP website as well, and is not limited to tower or desktop models, but also includes a range of rack-mountable QNAP devices as well. We also have an Ethernet switch, and we'll be using a Windows client to connect to these. From a configuration standpoint, the host name of our first device is called TVS H474-1, and it's been assigned a static IP address of 172.16.0.201. Our second NAS device has been assigned a host name of TVS H474-2 and has been assigned a static IP address of 172.16.0.202. From a storage configuration standpoint, our first NAS device has a 12 terabyte hard drive installed in the first bay, and because they need to be identical, this is the same on our second NAS device. Let's take a look at how the networking is configured. So if we take a look at the back of these NASs, we can see that we have two onboard network ports, and in our example, we do have a 10 gigabit Ethernet card installed in one of the PCI Express expansion slots. We'll be setting up one of those onboard ports, which operates at up to 2.5 gigabits per second for our cluster network. And because we're using, as we're looking at it from the back, the left port, we'll also be using the left port on the second NAS device. This is for the cluster network. This is where the static IPs have been assigned, and they're attached to a switch. For the heartbeat connection, we are using the 10 gigabit connection because we want to make sure that any data synchronization that happens quickly, and that is directly attached and connected between the two NAS devices. And this connection is assigned a DHCP, an IP address via DHCP. With the initial setup and the connection out of the way, let's now actually take a look at how we would set up high availability in a live demo. Okay, so what we're going to do now is take a look at how we would set up QNAP's High Availability Manager and set up a cluster with two QNAP NAS devices. First thing is we'll take a look at our first QNAP device. I'm going to fire up our web browser and I'm going to navigate to our first NAS. This is a TVS H474 NAS, which is a 4-bay NAS, and I've given it the name TVS H474-1. I've already set this up, and we'll take a look at how it's actually configured. So we'll just log in. So if we go to the control panel, we can take a look at the firmware version running on this particular system. It is 5.3.0.3192. It has 8 gig of RAM, which is the minimum required to run QNAP High Availability Manager. And if we take a look at the networking configuration, the TVS H474 comes with two 2.5 gigabit Ethernet ports on board, and it has expansion slots which allow you to install additional network cards. In this particular NAS, I have the two 2.5 gig onboard ports, and I have a 10 gig network card installed in one of the expansion slots. For high availability, you need to use one network port for your client access. So that'll be all your servers or your PCs, your clients that will be accessing the NAS, whether that's through shares or through iSCSI for block devices. Or you could have that as a team if you like. High availability will then use a second network port or a second network connection for maintaining the heartbeat between the primary and secondary NAS devices, and it will also use that connection to synchronize the data from the primary to the secondary NAS. So in our example, we have a network port on the 2.5 gig for that client access, and you can see that's been given an IP address of 172.16.0.201. And important to note is the heartbeat slash cluster network for high availability needs to be set to DHCP, and that needs to be directly attached between the two NASs, so it should not go through a switch. The client connection can and should go through the switch as normal. So you can see there, our adapter 3, which is our 10 gigabit adapter, has a 169 address, which is a DHCP address when you can't find the DHCP server. So that address is, or that interface is set up correctly. Next thing we'll do is we'll take a look at the storage. And if we go to the disks, you can see that we have a 4-bay NAS with 2 M.2 slots. However, only one drive bay is populated, and that is this 3.5-inch SATA bay, which has a 12 terabyte drive in there. I don't have many disks for this demo, purely because it is for demonstration purposes. In a real-world situation, you would most likely have multiple drives set up in a RAID to provide a level of disk protection for the data you're storing on the NAS. For our demonstration, though, this will do perfectly fine. If we go to the overview, we can see that we don't have any errors, and our NAS is in a ready and good state. What I'll do now is take a look at the secondary NAS. So we'll open the link there. You'll notice that this has an address of 172.16.0.202, and I've given it the name TVS H474-2. So we'll log into this NAS as well. And just like before, let's take a look at the control panel. We can see that the firmware version is the same, which is 5.3.0.3192, and this also has 8 gig of RAM. Keep in mind the configurations of the two NAS devices need to be identical. That means the same firmware version, the same memory, the same drive configuration with the same drive capacities, and the networking needs to be the same as well. Obviously, the IP addresses will be different, but the network setup needs to be almost identical. With that said, let's take a look at the networking on this device. We can see again, we have the two 2.5 gig network ports which are on board, and we have a 10 gig network card installed in one of the expansion slots. Networking wise, they're on the same subnet. As I mentioned, the IP address here is 172.16.0.202, and adapter 3, which is a 10 gig connection for heartbeat clustering and synchronizing data. That's a DHCP address. There is no DHCP server because the NASs are configured to each other, are connected to each other directly over the cluster port. So that's assigned automatically there. If we take a look at the storage again, we have no errors, no warnings, and we're in a good and ready state. As far as the first NAS is concerned, our primary NAS, if we take a look at the shares that are configured, I have a share here called TVS H474-share, and we have a couple of folders in there. We've got a documents folder which has a series of PDFs, and we have an ISO folder with a number of ISO files in there as well. If we go to our client machine which we're on and take a look, you can see that I've mapped that share as a Z drive. You can see the host name there is TVS H474-1. If we open this, you'll see there's our share, there's our documents folder, and there are our ISO files. So this is mapped. We can see the contents of this NAS. Let's now go ahead and set up QNAP High Availability. To do so, we need to ensure that we have the QNAP High Availability Manager software installed on both the source and destination NAS devices. To do that, we'll open the App Center. You'll notice that the High Availability Manager software is not in this list. It's not installed. So we'll go ahead and we'll do a search for High Availability. If I can type that correctly, there it is, High Availability, and let's install that. While that's installing, I'm going to go ahead and do the same thing on my secondary NAS, on my target NAS. So we've gone to the -2 NAS device. We'll open App Center. Again, we'll see that we don't have the High Availability Manager installed. We'll do a search for High Availability, and we'll go ahead and install that. So this will take a few minutes to go through to download and install. We'll let that continue in the background, and we'll go back to our first NAS, and you'll see it's now installed. It's ready to open. If I click on all apps, or my apps, the ones that are installed on the system, you'll see that High Availability Manager is now here, and we can open that. Before I do, I'll just go back and make sure that it's finished installing on the second NAS. So it's almost there, it's just finishing the install, and now it's installed. So if we go to My Apps, we can see High Availability Manager is set up here as well. What I like to do is set it up from our primary system. So we've gone back to the TVS H474-1 NAS, our primary NAS that has our shares configured on it. We'll open High Availability Manager. This will launch a wizard and we can go ahead and create a cluster. So here it's telling us we'll have an active and a passive node once it's done. So we'll go ahead and start the creation. It's telling us what the requirements are. And again, to reiterate, we must have 2 of the same model NAS. The firmware version on them needs to be the same. The amount of memory on them needs to be the same. The version of High Availability Manager needs to be the same and must be installed on both the source and target. If there are any other licenses that you may be using, they need to be consistent and the same across both. And if you're using any applications that don't support high availability, they must be disabled. A full list of those, which is an ongoing list, is available on the QNAP website. From a storage standpoint, you must have the same number of drives of the same capacity in the same bays or slots on both devices. Networking, we need to have the IP addresses in the same subnet for client access, and then we need to have the same number of network interfaces and using the same ports on those particular systems. So we'll go ahead and we'll do that. We'll click Next, and here you'll see the diagram. We have the heartbeat connection, which is between the active and the passive, directly connected between the two. In our example, that was the 10 gigabit connection because the synchronization of the data happens over that connection as well. Then we have the cluster connection. So if you're familiar with clusters, it'll be in a similar way where we will create a cluster name and an IP address that is associated with that cluster. And that IP will be used to access the active node. If the active node were to fail or become unavailable, the cluster name and IP address would then get reassigned and point to the passive node, which becomes active. So by using the connection to the cluster IP or the cluster name, we ensure continued access to our NAS resources. So here we're going to choose what is our cluster connection. So you'll notice there are the 3 network adapters, and one of them is in our production subnet, which is this 172.16 network. So we're going to select that as our cluster connection. For the heartbeat, we're going to choose adapter 3, and we're going to click Next. It's now connecting to the passive node, and it will know that through the heartbeat connection. So we'll give that a few seconds for it to try to connect. So it's connected, and now in order to log into the passive node, we need to provide the administrator username and password. So I will go ahead and put those in. So we've connected, and now it's just doing a quick comparison of the different specs. So the models are the same, the firmware is the same, memory is the same, the host names are different, which they need to be. Application status is good. From a storage standpoint, everything is consistent and good and available. And the networking is also available. So it's passed all the checks. We can now click Next. We now need to give the cluster a name. Now, I've named our 2 NAS devices TVS H474-1 and -2, as we can see from the names here. I'm going to give the cluster just the H474 name, or we could even go oh, that's too long. We could call it -C for cluster, or I'm just going to leave it as H474. we now need to assign an IP address for the cluster itself. So I'm going to give this an IP address of 0.200 for the cluster. So the cluster will be 200, node 1 or the active node will be .201, and the passive node or the secondary node will be .202. I'm happy with that. I'll go next. So it's just double checking everything. We're ready to go. We're confirming the settings and we click create to make that happen. So we get a warning here. In order for the high availability cluster to be created, it's telling us that all services on the active node will temporarily be suspended and all data on the passive node will be wiped because it will effectively become a copy of what's on the primary. If you have active users and if there's data being accessed and used on the primary, continuing will cause interruption to access of that data. So you want to make sure that you do this during a downtime or a time when users are not using the NAS. In our case, there are no active users apart from us. We're not using it. So we're fine understanding those conditions and we'll click OK to continue. So here we have a progress bar or a progress list. And this can take several minutes to complete. So again, the first part is completed. It's now going through step 2, which is setting up the environment. So we've gone to step 3. Now to step 4. Finally, the last step, starting all the services, bringing everything back online. And we're done. So now what we need to do is connect to the cluster instance. So if we go to leave the page, you'll see that it's redirected at us to 172.16.0.200, and you'll see the host name is just TVS H474. There's no -1 or -2. We're now connecting to the cluster instance. And we will do so using the same username and password that we had for our nodes. And you can see here, High Availability Manager is starting. It's showing us that the active node is -1, and it is going to the passive node, which is the -2 node, and it's showing synchronizing data from active node to passive node. So here's our transfer speed and the latency, and we have the different resource utilization information and the data synchronization status. So what we're going to do is we're going to wait until the data is synchronized, and then we're going to make sure that we can access the share, the clustered share now from our client machine. So again, we'll just give that a few minutes to synchronize. And what we'll need to do is we'll need to connect to the share using the cluster instance. You'll see here, the share is no longer available from the node 1 access directly. So we're going to go ahead and we're going to remove that share, and we're going to create a new share. So let's do a new mapping, and this time we're going to map it and if we do a browse, so we are going to connect as QNAP, and we're going to put our password in, and we're going to connect to this share. And we can see that the share with the documents folder with the PDFs and the ISO folder with our ISO files there are available under that share. I'm just going to close this, and we'll go back to the High Availability Manager. We can see that the cluster is healthy. and that the data is now synchronized. So if I was to go ahead and put a new file in our share, so if I was to go to, say, our documents, and I was to create a new text file here and call it test doc, and open that with Notepad and save our file. There it is. We can see the contents. Now, you can see the data has been transferred. We're okay. We're in sync. We're healthy. What we're going to do is, actually, let's reopen the share on there. What we'll do is we're going to simulate a node failure. I'm going to remove the power from the active node. I'm not going to do it gracefully. I'm just going to pull the power out of the back of the NAS. So you can't see, but I've gone ahead and I've unplugged that NAS. And if we come to the High Availability Manager, we should shortly see a disruption in the heartbeat status. And if I try to access my share, it's currently gone down while it goes through the failover process. So you can see here it's taking a bit of time. I've unplugged the power from that active node. If I come to the High Availability Manager and click on Nodes, it won't be able to access the active node. You can see here now that H474-1 is now the passive node, and -2 is the active node. So if we come here, it was loading the documents folder, and now I can access that. If I go back to my share and open that, I open my documents, there it is, my test doc file is there. We open that up, it says hello world. I do get an alert saying that High Availability Manager has done a failover. And if we go back to the cluster dashboard, we can see here it's unable to detect our node, the -1 node. So we have a disconnected node, but we have access to our files. We have access to our share. And that entire failover took less than a minute. It may have taken at most about 30 seconds for that to detect, process, and do a switchover. Now, if I was to power on that failed node, maybe someone unplugged the power cord accidentally. So I'm going to go ahead and power that back on. And that might take a couple of minutes to boot up. But we'll see what happens once that node comes back online. Now, there are some cluster settings you can look at and look at the failover policy. There is an option to enable a quorum server if you want to make sure that if a disconnection or communication error happens, you can provide an additional safeguard for choosing which node should be the active. And then you've got language options, and you can see the network detail there, and you can change the high availability network through here once your cluster's in a healthy state. And then we have the event logs. As I mentioned, we had the logs around the failover. We'll come back to the cluster dashboard here. My NAS just did a couple of beeps, so it's almost finished booting. So again, we'll just give that another minute or so. And again, until that comes online, we can see our synchronization state is in a warning state because we only have the one copy of the data. We can see here the heartbeat has now re-established, and we can see the transfers are happening and they're going in right to left direction. We're still waiting for the NAS to completely boot up. Okay, still going. You can't see it on screen, but it's showing the status as starting services on the NAS itself. Okay, we're still syncing, starting services. Okay, our NAS should be now powered back up, and we should get a update on the status of the passive node very, very shortly. Again, making sure we still have access to our share regardless of the condition of that primary NAS. Passive, that what was once the active node, which is now passive. So my files are still there, I can see them. If I go to nodes, a passive node still showing as offline, active node has all the information there. Come back to the cluster. Okay, and now we can see here, we've got the IP address of the passive node, which is the -1 machine. Our cluster is healthy, and the active node is still -2 because of the failover. We've still got data synchronization happening, and now we're good. So you can see the data synchronization status is good. The direction of the replication is from -2 to -1 because -2 is still the active node. So now it's making sure that any data that may have been written to the active node during the failover is being copied and synchronized over to the node that failed, which is our -1 node in our example here. So like before with the initial synchronization, you can't do any firmware updates or you can't do a switchover of the roles while the data is still synchronizing. But once the data is in sync, which should happen very quickly in our case because we didn't really have a lot of data being written or changed or overwritten during that failover period. So now it wants us to reload our page. If we open High Availability Manager, -1 has become the active node again. So we've had an automatic failback as part of the failover and failback process. A couple of more things to show. If we click on the Manage or hover over the Manage button, we can do firmware updates, we can update the High Availability Manager software, or we can initiate a manual switchover from active to passive, where passive becomes the active. We can remove the passive node, or we can remove the cluster altogether. And then on the power button, we can either shut down the cluster or restart the cluster, and we can do this in a managed and graceful fashion. If we come back to our share, let's just go back to the PC level. We'll open the share. Again, it's just pointing to the cluster instance. Our documents are here. Our ISO files are here. And with that, that concludes the demo of setting up and initiating a failover and failback with QNAP's High Availability Manager. Thank you.